Determine whether the relation is a function. Give the domain and the range of the relation. So a relation is just two quantities being related to each other. For example, in this case, we have ordered pairs where X is related to Y. So we have 3 related to 2, 3 related to 6, 4 related to 2, and 4 related to 6. Now, if this is a function, each X, remember ordered pairs are X, Y, each X can have only one Y. So for the X of 3, also called the input of 3, it can only have one output. So we have 3 with an output of 2, and then, we have 3 with an output of 6. So this is not a function. Now we have to give the domain and the range, and all that means the domain is the set of input values or X values. So we just list the unique X's. So I've got 3s and I've got 4s. So I'm just going to list 3, 4. I do not have to double list the 3 or the 4. They just need to be listed one time. And the range is the set of outputs, or in this case, the Y values. So we've got a 2 and a 6, and then they repeat. So once again, for this range, we just put 2, 6. Here's another set of ordered pairs. We've got our input or domain values, 9, -5, 4, and 7, and those are all unique. Therefore, this is a function because the only output for the input of 9, that is the only Y for the input of X, is 9. So is it a function? Yes, it is. Remember, if X repeats itself, its Y has to be the same every time. And in this case, X is not repeated, so it's a function. The domain is the set of all the X's. So 9, -5, 4, and 7. 9, -5, 4, and 7. Let's separate those with commas. The range is the set of output second values, or in ordered pair X, Y, it would be the Y values. So 9, -5, 4, and 7. It just happens to be the same as the input values, the domain values, but that's not necessary. But they are, all of the Y values are our range. Now we have to determine whether or not an equation represents Y as a function of X. Do we have a function here where Y can be determined by the values of X and be determined uniquely? There's only one thing in this course that you have to worry about not being a function where Y is a function of X, and that is if you have Y squared. If you have a Y squared, you are not going to have a function. Okay, so Y squared is not a function. Okay, so look at these variables. We do not have a Y squared, so yes, this is a function. I mean, it literally is that easy. Look for a Y squared. If you have a Y squared, nope, not a function. Otherwise, yes. Here's one where we have that problem of having a Y squared. So no, this is not a function. It turns out that this is the equation of a circle. Now, it can be an equation and it can be graphed on the coordinate plane and not be a function. Here we have a y and it's not squared, so yes, this is a function. Here we have a y in two different terms, but neither of them is squared, so yes, this is a function. Here we have an absolute value bars around our x, but our y, again, is not squared, so yes, this is a function. Now remember, x can be squared, it's y that can't be squared for y to be a function of x. Now they're asking us to evaluate a function, and evaluate means find the value of. So they give us a rule. This is called a function rule, and this is function notation. There's a function named f, where their input values are defined as x's. Those are your domain values. And then they give us those values that we are to input for x to get out the function value. And the function value is technically the y value, okay? So f of x is the same as y, okay? That's the output value or the second value you get when you put in an x value. So let's evaluate this function. So our function is f of x is x squared plus 5x plus 4. And we're supposed to evaluate that at 2. So f of 2 means, now here's a sort of some advice. When you're inputting your input values, always put them in parentheses. That will prevent some tremendous issues down the line when your input is either a negative or a variable. So be sure that you put parentheses around them. I didn't have to in this case. The parentheses here mean to multiply. I could have used a dot and I could have just written 2 squared. But when we get ready to do one that has a negative, this is going to be helpful. So doing the arithmetic, 2 squared is 4. 5 times 2 is 10, plus 4, that is a value of 18. So f of 2 for the function, x squared plus 5x plus 4, is 18. Now, if we were to plot this point or use this to graph this function, this would be our x and this would be our y. 2, 18 is the ordered pair that corresponds to this. Now, they didn't ask us for this, but it's important to know for later. Now we're going to do f of x plus 5. Now, here's where those parentheses come in handy, because you've got an x squared plus a 5 times x plus 4. And in this case, I have to put in an x plus 5 and an x plus 5. So that's going to give me x squared plus 10x plus 25. Now you may be saying, well, where did you get the 10x? Well, you need to remember that x plus 5 squared means multiply that binomial by itself and use the FOIL rule. Remember FOIL? First 2, x squared, outer 2, 5x, inner 2, 5x, last 2, 25. And look, these two 5x's make that 10x. So don't forget, that's a common mistake, is to put x squared plus 25 and lose completely that middle term of 10x. Now I have to distribute here 5 times x plus 5 times 5, so that's 5x plus 25, and having those parentheses reminds me I have to do distributive. And then there's a plus 4. So last thing, combine like terms, x squared, 10 and 5 is 15x plus, there's got to be an x in there, 54, because 25 plus 25 plus 4 is 54. All right, so f of 2, we got 18. So let's go ahead and enter that and check it. Okay, now we've done our f of x plus 5, and we got x squared plus 15x plus 54x squared. You can use this exponent key or use the caret key. That is the caret key that's on your shift 6 on your keyboard. X squared plus 15x plus 54. All right, so we'll check that answer. All right. Now the last part is to put in negative x, the opposite of x. So f of negative x, need the parentheses here, negative x squared plus 5 times negative x plus 4. All right, I got to watch my signs here. A negative times a negative is a positive x squared. A positive times a negative is a minus 5x. And then we have plus 4. So the answer to this one is x to the second. Again, you can use this key or the caret key, which is shift 6 on your keyboard. X squared minus 5x plus 4. So that is evaluating a function for given values. All right, so we're going to evaluate the function h of x equals x to the 4th plus 3x to the 2nd plus 7. And we're going to do h of 1. That's 1 to the 4th plus 3 times 1 squared. Now, I didn't put my parentheses like I had advised. When the number's positive, excuse me, when the number is positive, it's not absolutely necessary. But when it's negative or has a variable, you have to. So that's 1 plus 3 plus 7. That turns out to be 11. So put in 11. Check our answer. Now we're going to put in a negative 1. So we've got h of negative 1 is going to be negative 1 to the 4th. Need that set of parentheses this time. Plus 3 times negative 1 to the 2nd plus 7. Now you could actually type this in your TI-30X2S exactly as you see it, okay? As long as you got the parentheses, it'll do it right. Doing it manually, 1 times 1 times 1 times 1 is going to be 1. Negative 1 times negative 1 times negative 1 times negative 1 is also going to be 1. Same thing here. A negative 1 times a negative 1 is a positive 1, so that's a 3 plus a 7. And so this time the answer is also 11. So I will enter and check my answer, negative 11. Whoops. What did we do wrong? Now this is a good time to see, a good time to evaluate when we're making mistakes. Okay, so here's what I would do. I'm going to go back and I'm going to make sure I copy the problem right. X to the 4th plus 3x squared plus 7. Okay, that's right. And then, oh, I put negative 11. Well, that's crazy. Let's just fix that. Okay, great. That's just a careless error. Be careful about that. The good thing is you'll notice how it didn't mark me wrong. In MyMathLab, you can try 3 times before you actually end up getting penalized. So, great. All right, next one. We've got to evaluate the function h at negative x. So again, parentheses are needed. Negative x to the fourth, 3 times negative x squared plus 7. So I carefully, each time I have an x, I put in the negative x in parentheses. This is just going to turn out to be x to the fourth plus 3x squared plus 7. And we're going to learn later that when you evaluate a function for the opposite of x and it comes out the same, that means something special about the kind of function you have and the kind of symmetry, that is, the identical side of the graph on both sides of something are identical. The graph is identical on the right and the left based on this evaluation. And we'll see that a little bit later, but let's just go ahead and type this in. X to the fourth plus 3x to the second. Again, I'm using the caret key on my keyboard, plus 7. Check my answer. Got it right. They do want us to do one more here. They want us to do h of 3a. So again, I need those parentheses. H of 3a is going to be 3a to the fourth plus 3 times 3a to the second plus 7. Now, this is a rule of exponents. When you have a product, not a sum or difference, two things that are multiplied or divided, actually, raised to a power, they both receive the power. So 3 to the fourth, a to the fourth, plus 3 times 3 to the second, a to the second, plus 7. Now I'm going to go down and I'm going to get my calculator out and I'm going to do 3 to the fourth. Okay, that's 3 times 3 times 3 times 3, which is 81. A to the fourth plus, now that's 9, and 3 times 9 is 27. A to the second plus 7. 81, a to the fourth plus 27a squared plus 7. And we'll very carefully enter my answer this time. Try not to make any mistakes. 81a to the fourth plus 27a to the second plus 7. Okay, so another evaluation problem. Evaluate the function at the given values of the independent variable. The independent variable is actually the input variable. Independent input, that's the x. So look, given values of x is what they mean. So I've got f of x is 3 times 3 squared minus 1 over 3 squared. Now don't try canceling out anything. Go ahead and do the numerator completely, the denominator completely, and then reduce if you can. So that's 3 times 9 minus 1 over 9. Again, no cancellation allowed. And the reason is this subtract 1. Those are stuck together up there. This order of operations, the fraction bar is one of the grouping symbols that says do all this up top, all this on bottom. Without putting parentheses, that's what it's telling you. 27 minus 1 is 26. 26 over 9 is our answer. So 26, and I can use this fraction key, or I can use the slash key down by my shift key. 26 over 9. Now we have to do f of negative 3. So f of negative 3, and I want you to watch how I'm doing this. You need to write it out this way on your paper. 3 times negative 3 squared minus 1 over negative 3 squared. So we're identifying what we're doing, and then we're actually inputting that value. In the next line, I'll start to simplify. 3 times 9 minus 1 over 9. You'll notice it's going to come out the same as it did a minute ago. 26 over 9. We type it in the answer box. 26 / key 9. Check our answer. That's correct. So the last one here is to do f of negative x. So f of negative x, 3 times negative x in parentheses squared minus 1 over negative x in parentheses squared. So that's 3x squared, because a negative times a negative is a positive. Subtract 1 over x squared. And you'll notice again, like on the last one, this is the same as the original function, and that will later on tell us about this function. It tells us about its symmetry, and it tells us about its shape in some ways. So 3x to the second, subtract 1. I'm going to highlight that and hit my fraction key, and then I'll put in x to the second. So did you see how I did that? I went ahead and did the whole numerator, 3x to the second minus 1. Highlight the whole thing, hit the fraction key, and then x to the second. You can also hit the fraction key first. Question 11. Use the vertical line test to determine if y is a function of x. So we'll call this the VLT. The VLT is the vertical line test. And what it says is when you have a graph of a function, a vertical line can touch the graph only once. So if I have a circle, you'll notice it touches it twice. Okay. If I have a graph like this, it only touches it once, no matter where I draw it. So all we have to do is look at our graph. It's this blue line. If we draw vertical lines on this, it will only touch it once. Each line would only touch it once. So yes, it is a function. But there's not a circle. This is actually called an ellipse. It's a flattened circle. And notice this y is this y-axis is a vertical line. So it crosses it here and here. So y is not a function of x. Okay. Look at my graph. If I draw a vertical line here once, here once, here once, so yes, y is a function of x. So the vertical line test is a very fast way to decide if a graph is a function. And the good news is it's easy, it's fast. If you happen to have the graph, all you have to do is just draw that vertical line. If it hits it twice, boom, it's not a function. Okay, so we're going to use the graph of f. So here's our graph of f they give us. Looks like a trig function. To find the value f negative 6. Okay, so let's see. That means x is negative 6. So I go over here and I say x is negative 6. And I go down to my graph, and it's at a y of negative 2. So in that case, the input or the domain value is negative 6. The output or the y value is negative 2. Now we're going to use the graph to find the value f negative 4. That means x is negative 4. So go over here, negative 4, and I go till I see the graph, and that's at 9. So f of negative 4 is 9. The first value will be on the x-axis. Remember, ordered pairs are x, y, right? X, y. So you go to the x-axis first, -4, follow that vertical line until you touch the graph, and it's at +9. All right, so this time they give us a function. They like to change the name sometime. They call it g. Okay, that's just the name of the function. 9 is the x value. So I got to go over here till I can see the x value. Oh, and look, we don't even see 9, but look, see how this is flattened out with an arrow there? Even if they don't put the arrow, generally, if a graph goes to the edge of your little coordinate plane, that means it continues. If it doesn't continue, they put a solid circle like that, but there would be no arrow or anything on the end. Now, this says that at 6, it's at -4. At 7, it's at -4. At 8, it's at -4. So we can assume that at 9, it's at -4. For what value of x is g of x equal to -3? So this is different because they didn't give us the x, they gave us the y. So I go to my y-axis and I find my -3. And then I've got to go over to the graph and I see that would be +3. So if x is 3, y is -3. So this would be x is 3. Can't get it to check. Hold on 1 minute. Let's see if I can get it to check. All right. Use the graph to determine A, the function's domain. That's all the possible x's. B, the function's range. That's all the possible y's. C, the x-intercepts. That's where it crosses the x-axis, if any. D, the y-intercept, if any. And E, the missing function values below. So we're going to use interval notation on this, so let's talk about that for just a minute. In interval notation, you have either a bracket or a parentheses, and I'll tell you which one and why. And the smallest value first. Then there's a comma, the largest value, and then either a parentheses or a bracket. Now, the bracket means included. That's what the bracket means. The parentheses means the largest value or the smallest value, whichever end it's on, is not included. Okay, so let me just do a number line first. Let's say I had this number line. That's an open circle. And that's a closed circle. And this was a 3, and this was a 10. Well, in interval notation, this would be 3 with a parentheses, because 3 is not included, 10 with a bracket. Okay, so that's interval notation. Now, when we do our domain, we read it left to right. And we have to remember, if it goes forever that way, that's negative infinity. And if it goes forever that way, it's positive infinity, okay? And we never include infinity, because to include infinity means you can reach it. But that's what infinity means, is that you can't reach it. It goes forever. So we're going to take a look at this graph. And we have, now it looks like it's just going up, but this graph goes like this. And as it goes up, it also spreads out that way. As it goes up, it also spreads out that way. So its domain is going to eventually be negative infinity to positive infinity. Because eventually, as this graph spreads left to right and goes up, it would be going forever to the left and forever to the right. Now, that's not true with the range. The range is read from bottom to top. That's smallest to largest on the y-axis. And if you look at this graph, you see that it has a ending point. It doesn't exist down here below -1. So it goes from -1 to positive infinity. And you do not have to write the positive on the infinity. I have a habit of doing it, but it is not required. So we said our domain is, and look, here's our little infinity symbol down here. So negative, we have to write infinity, comma, positive infinity, parentheses. Now notice, with infinity, you always use the parentheses. Okay, we check this. All right. And now we said our range was, we drop down bracket -1 because it's included. If it wasn't, they have to put a clear open circle, comma, it's going to rise forever. That's infinity or positive infinity.